In the Brilliant Guide, page 116, question 6, it is entitled by Principle of Interaction. They're telling us that the figure below, which means this one, shows two electric charged balls that repel each other as long as they are electrically charged spheres and they are repelling each other. This means that they have the same charges. So, like either both are positively charged or both are negatively charged. The figure is drawn to the scale 1 centimeter to, and every 1 centimeter represents 0.5 in Newton. And we are not given this vector, we are given only this vector. If we measure this vector, it is 2 centimeter in length. So, just like before reading the questions, I'm trying to read the given. So this vector, force exerted by A on B, is 2 centimeter in length, and the scale is every 1 centimeter represents 0.5 in Newton. So doing cross multiplication, just as asked in number 1, find the magnitude of the force exerted by ball A on B. So doing the cross multiplication, 2 centimeter FA on B, the value opposite to it, we put it in the denominator and we'll multiply the other two ones opposing each other. 2 centimeter times 0.5 in Newton, centimeter and centimeter, they cancel. So unit-wise, we are kept with a Newton, which is logical because we are looking for the magnitude of a force and the SI unit of magnitude is Newton. And the value is 2 times 0.5 is 1 over 1 is 1. Now for number 2, name and state the law applied to find the magnitude of the force exerted by ball B on ball A. So we are given that they are repelling each other. This means that B is repelling A, and B is exerting a force on A, and A is repelling B. This means that A is exerting a force on B. So like for FA on B, it's already given. What about FB on A, and how is it related to FA on B? So that's why they as if gave you a hint by asking you to name and state the law applied. So by principle of interaction, if a body A exerts on a body B a force Fa on B, then at the same time B exerts a force Fb on A on body A such that Fa on B equal minus Fb on A. This expression here means that these two forces are opposite forces, and the minus sign here represents this. So they have the same line of action, same magnitude, but opposite direction. Here I have to mention that we cannot add them. We cannot express it in a way that we say Fa on B vector plus Fb on A vector equals 0 vector by bringing this one to the other side. That's absolutely wrong because we cannot add two vectors acting on different bodies. On one side, this is acting on B, and on the other side, this vector is acting on A. So we can never add two forces acting on different bodies. One is affecting A, the other one is affecting B. Hope this idea is clear. So for part 3, indicate the characteristics of the forces of interaction between the two balls. Point of application, as long as we're talking about electric force and repulsion, then this means that this is a force acting at a distance. So the interaction is taking place at a distance, and the point of application is the center of gravity. Fa on B, we have to look on B what is happening to B. B is being repelled to the right. So the point of application is the center of gravity of the ball B, or of the sphere B, line of action horizontal to the right, and the magnitude is 1 Newton already calculated in part 1. What about Fb on A vector? Point of application, it's acting on A. So it is the center, the point of application is the center of the gravity of the ball A, and the line of action also horizontal. However, having opposite direction, what is B doing on A? It's repelling it to the opposite side, to the left. And by a principle of interaction, they have equal magnitudes, which is 1 in Newton. Now for part 5, they're asking for part 4, they asked to represent the forces of interaction between the two balls to the given scale. So as long as they are equal in magnitude, the force vector Fb on A is going to be also 2 centimeter in length. However, its point of application is the center of gravity of A, and it is to the left. For 6, for 5, name and classify the forces acting on ball A. Now talking about A alone independently, there are 3 forces acting on it. The tension by the wire here, the electric force that we mentioned, and the weight. And the tension is contact, weight is acting at a distance, and the electric force is acting at a distance. Indicating the characteristics